we have realized industrial online monitoring of the molten alloys component by laser-induced breakdown spectroscopy. By this technology, main and trace element of the molten alloys can be analyzed in real time. A vacuum induction smelting furnace can smelt for alloy refining, and this is the most popular method for refining alloys. Analysis of the molten material components during the course of industrial processes can effectively improve the production quality. LIBS has the advantages of fast and long-distance analysis. It is a good method to realize online ingredient analysis for industrial application. Demonstrating the procedure will be Li and Shanghai Zhao, a PhD student and technician from my laboratory.
To begin this procedure, analyze the standard samples and construct the calibration curve of the quantitative analysis as outlined in the text protocol. Then, put the unknown sample into the smelting system. Next, open the laser generator and realize the pulse laser output using a pulse width of 20 nanoseconds, a frequency of 5 Hz, and an energy of 90 millijoules for each pulse. Open the spectrometer and the spectrum deposit software and determine the spectrum using a spectral range of 190 to 600 nanometers, a resolution of 0.06 nanometers at a wavelength of 200 nanometers, and an integration time of 10 milliseconds. After this, adjust the laser focusing position and optimize it until the strongest spectrum signal is attained. Determine the laser breakdown spectrum, taking note that each laser pulse generates a frame of the spectrum and that 20 frames of